Welcome to another exciting video. So in this one I'm repairing a customer's soldering job on the mintyPi version 3 here. They said it would overheat and just kind of shut down, so I checked it out. We did the solder that looked really ugly on the top here. Once I did that, I used some wick and my favorite flux, the Amtech. And I sucked up a lot of the bubbles and the nasty burned on whatever it was, and it somewhat solved the issue, but some buttons would randomly be pressed, and as I was heating each individual GPIO which had the solder, I can hear it sound like bubbling. I actually saw some splashing from the top row coming from under the board, so that told me one of two things. They either used some flux that was no clean flux, or they used maybe some solder paste, something that had flux in it, and that was the cheap kind that usually causes continuity and can corrode on some of them, but this one in particular didn't corrode from what I could tell. So I try to suck it all up, and I removed the pie, and I could tell that there was they used solder paste because there was still some residue left over, especially on this GPIO. Some where the TV and run, actually some went on there, a bunch of other stuff. It was pretty nasty under here. So my recommendation, whenever you do any kind of mintyPis or anything where you're going to solder the Raspberry Pi Zero directly to the board, don't use flux. Flux is not even needed. You know, some people like to use it for that security, that little, security blanket. It makes them feel like, okay, I'm gonna do a good job, I'm not gonna screw it up. But you don't even need that. I never use flux on this. There's no need for it. So on the on the mintyPi Lite and version 3, it's pretty much a no-brainer. You put it in place here, make sure the hole here matches up with the 3D screw post, and just screw it down. This one can move, so this is the one you gotta really be mindful of. But the way we designed this, the 3D part along with the PCB, as long as this is screwed down properly, all the pads will match up. So by screwing it down, you're putting the most you're lining it up and also putting a little bit of pressure. But I could feel some play. So what I like to do is I start usually one of the corner ones on both sides while putting pressure down to make sure the solder, the PCBs are sandwiched as close as possible, and then once the solder solidifies, I hold it in place. So I like to do the two sides and a couple in the middle, just so it's pinched all the way through, and then I go one by one. To make the job work, you need the proper tools. So if you don't have one of these, it's nice and fine. I can actually go in there and I can feel the PCB if I move it around slowly. I can feel the bottom of it with this PCB. So that's what you want. It's kind of a, let me see if I can zoom in, show you guys, yeah, one of these tips. Almost like a needle nose. Very fine. This is what you need to do the job. And what we're doing here, we are not going to be jamming this in there with force. I got super fine solder. That's the kind I like to use. So the general rule of thumb is you stick it in the hole here, then you take the tip and you put it in. I like to hold it and I just kind of wiggle it around like in a circle just to make sure I'm touching the bottom, and then after about 3 or 4 seconds I pull up real quick. You'll see that the solder has like sunk in. I'll try to get a nice zoomed in so you guys can see. So the solder has sunk in there. You can see the wall of the GPIO. That's usually a really good connection right there. You don't need to have solder blobs like some people like to over use the solder so there's like a bunch that it bubbles up. You don't need that. So I could tell it's not really all the way down, so what I got to do is make sure I put some pressure here and just redo the hole. Hold it while it solidifies, about 2 seconds or so. And I can feel that's solid, that's not moving. So now we're going to go to the other side. Also be mindful, there are plenty of ground GPIO, which is this one here, I believe this one here, and a few others. So if you're going to do that, you need to keep quite a good amount of heat on there. That's usually the one that people have a lot of trouble with. So let's do this other corner. These two are 5 volts and this one's a 3.3 volt. So they're usually not super heat intensive. So here's what I do. I put the pressure down on this side and then pull up real quick. That's on there good. So now we'll choose anything in the middle. Preferably not a ground. That's a ground I could tell by looking at it. We'll do this one here. We'll stick the solder in the hole. The tip goes in. Put a little bit of pressure down. I like to rotate. You don't have to, but then I pull up real quick. The solder sinks in, making contact with the pads right here on the PCB. So I'm going to do another one over here. This is a ground also right there, and these look like general pins, so we'll use this one here. Stick it in a hole, put the tip in there, a little bit of pressure near the GPIO, and pull out real quick. We'll do a continuity test at the end, of course, just make sure everything's good. But this is the general idea. So this is a ground, so this is going to take a little longer to heat up. So what I do is I just keep it there longer. Make sure the solder is molten. I hope you can see that in the video here, in the camera. And then pull out real quick. This one did not go as deep in the hole, but that's okay. Because ground usually solidifies pretty quick. And these narrow tips like this, they don't have a lot of surface area to transfer heat. But that's what we need to get into the holes. Some people like to use Captain tape, not necessary either. This was designed in mind where nothing should be touching the back of this board. Again, it's one of those safety blankets that some people need, but as I've said, not really needed. Sometimes I put the tip in a little bit and I just add solder, and the melted solder will go down, especially when I put the iron straight up like this. Now it's kind of hard to see with the camera. I'll try to turn it a little bit. Pull up. Tip starts to get a little dirty. Clean it. I always want a nice clean tip. If you have too much excess solder, it can give you crappy joints, bubble up. You know, as you can see, all my solder has gone into the GPIO. There's nothing bubbling over. If you have too much solder, that could happen. Not saying it's wrong or it's bad, but I know this way I could see that the solder has sunk into the GPIO, making contact with the pad on the board here. This way I know for a fact it's probably a solid connection. You probably, I think the camera caught that one pretty good. As I pulled up, the solder just sunk down. Let's see if we can do the same thing here. Remember, what I'm doing, I'm just pretty much just holding the iron in place. I'm not putting pressure down, because some people I've had them complain that, oh, this button's not working or that button's not working. It's because they jammed this down, and this is a really thin board. It's like 0.6 millimeters. So, and ground plane is on the front and back. If you put too much pressure, you could puncture this, and you're going to be touching the tip of the iron on the back, where it's totally ground. So that button is going to be grounded. It's almost impossible without removing the pie and scraping the inside, the middle of the pad, so that there's no contact going to the ground anymore. It's such a pain. So you don't want to jam or put pressure. I'm just holding the iron up. I'll angle it a little bit so you guys can see it better. All I'm doing is holding it up. Hold it up and then pull it out. Two, 3 seconds in there, pull it out. It just sinks right in. This one we already did. That was one of the ones we used to anchor the middle, so we can skip that one. Trying to do it so you guys can see in the camera. But the technique is the same one I've been using on these previous ones, so nothing's really changed. If anybody's interested in knowing what my soldering iron is on this particular tip here, the iron I use is the Hakko FX-951 or 01. It's a knockoff. Basically, you want anything that's like a T12. T12 tip iron. They sell them for like 40-45 bucks. They have the best iron tips. It's these long tips that go in there. This one has awesome surface area. This is how I removed this Raspberry Pi from this board. I used this tip, which has a crazy amount of surface area, and I used solder braid. As you can see there, this is huge. This is a lot of solder that I sucked up, and as I was sucking it up, the heat from that passed along the entire length of this and just heated up all the GPIOs. Then the pie just came right off. I did not even rip one pad off. So having the right tools makes the job smooth and works without any mistakes, anything messing up or ruining a customer's build here, their boards. I don't really have extras to be replacing. So you gotta do it the right the first time. So by me holding it up, it's kind of in the camera. So I'm going to angle it a little bit. But normally when you do, just hold it straight up. I'm just holding it with 2 fingers, and you just pull it right up, and solder sinks right in. Move it a little over here so you guys can kind of see the angle. I'm going to try to zoom in so you guys could see how it sinks. That's about as close as I can get, unfortunately. Just pay attention here. You should see the solder sink into the GPIO. That was a good one. Hopefully you guys saw that. Now, the reason you want to hold it a couple seconds is just to make sure it's nice and molten, so when you pull it out, it's almost like liquid. It just comes straight down. Again, you don't need flux, you don't need solder paste. All you need is a good iron tip like this and thin enough solder. The one I have here it's a Kester. I believe it's 0.4 millimeter diameter. Just a little thinner than this board in thickness. Anything up to 0.8 millimeter will work. I like the thin stuff. I have more control, more flow, and there's none of that splatter that some of the thicker ones have. So we'll do a continuity test when I'm all done, just to show you guys that, I might have one or two that might need a reflow, but might get lucky and all of them are good to go first shot. In Wormy's build video, he shows going over the GPIO that has extra solder on top with the solder braid, as I've shown the one that I used. But if you do it my method, you don't need to do any of that. I can run my finger. I don't feel a single thing. All I feel is actually the divots of the holes. This thing is barely smoking either. As you can see, no smoke at all, so I don't even need to have the fan on. So the flux is Kester 6337, 0.4 millimeter diameter. Okay. Clean the tip. Let's get a multimeter out. You don't need anything fancy. I use a Centec from Harbor Freight. It's like $5–6. Does the job. Try to get that in the screen so we can, well, let me zoom out, we can see the whole thing better. Okay. It did not come with these fancy leads. I got this from AliExpress. These are real nice. Super fine tip. So the B clock is the 6th one over here. Continuity. The L clock, I believe, is this 3rd one. Continuity. Den is this top one here. Continuity. B, if I'm not mistaken. There it is. Y. Right there. X is the next one. There we go. Start. Looks like we got one that needs a redone. I believe it's the fourth one. So all we gotta do is just put our iron in there. 1, 2, 3, 4. Hold it for 2 or 3 seconds, pull out real quick, and I can guarantee you that already solved the problem. Let's find out. The fourth one would start. Boom. Continuity. Ground. Most things have some kind of ground continuity, but you see the number? As long as it's over 500, it's fine. So ground is this bottom one here, and we have ground. This third one's also ground. We got ground. So R. Okay, there's our R. A button, I believe is the one above it. Yep. Select, sixth one on the bottom. Continuity. Mode button. It's one of these top ones. There it is. Screen clock. Okay, there's our screen clock. CS is usually right above it. There we go. Mode 2 is, I think, below. Reset. Mosey is down here. 3.3 volt, I believe, is also on the right. The DC is right above it. The Hall sensor. There we go. Up. Well, it might have a bad up. But let's just make sure. Yep. So that's our second one. It's not that bad. Let me just look over to the list where that is. Okay. So up is right here, which is this GPIO. So I'm not putting pressure. I'm just keeping the tip on there so it can heat up the solder. Sometimes you got to move it around a little bit. There we go. So the same thing as I've done. I'm just holding it with my 2 fingers, and I'm just going to pull up real quick. And now up should have continuity. Yes, it does. L. Yep. Down, which is this one. That's a ground. Down. There's down. The right should be the one above it. Or to the right. There. That's another ground. There's okay. Left. Okay. The TX pin is the fourth one. That I know. SCO. The I2C. I squared, as some people say it. Okay. 5 volts is this. We are golden. So we had 2 that had to get redone. But using my method, it was like a surefire way. One shot, pretty much almost everything. Just 2 we had to do. So, using the proper equipment gets the job done nice and easy. Let's try to zoom in so you guys can probably see a little better. As you can see, there's no raised surfaces. All the solder just sunk right in, and we have good connections on everything. So this thing is pretty much good to go. I'm just going to put the SD card in, test the buttons, and package it and send it back to the customer. Hope you guys learned something.